Bob again at racecarbook.com, airdensityonline.com. We've just finished off the analysis of the high-speed bypass for an optimum combination of a blown alcohol setup that we did an analysis on. I'm going to go back to baseline profiles. That setup, which was originally copied from the setup that was last run in the vehicle, it was problematic, is shown here. And it's got a really good 4-to-1 air-to-fuel ratio. If we take a further examination of this setup, what we're going to look at now is fuel distribution. Now, hat nozzles are all the same at 44 thousandths, and port nozzles are of different sizes that were developed over the years of racing the problematic combination. It's my suspicion that the fuel distribution would change now with a really good air-to-fuel ratio and a high-speed combination. To illustrate the types of things that should be considered in fuel distribution with nozzles, we're going to go over back to baseline profiles. And what we've done is we've loaded a third setup, which is a setup that we have evaluated from a nitro racing program that we finished. This is an interesting setup. It was a 1471 supercharger with 30% nitro. Okay. The blower is a 1-to-1, and the blower displacement was 543 cubic inches. That was from Mooneyham, the blower manufacturer, and it was a resealed blower, so we put that at 98%. My fuel pump flow was 12.53, and that came from an analysis that we presented in our Fuel Injection Racing Secrets book. All other provisions are shown in this combination. I'm not going to go into detail. However, I'm going to go over here to the nozzle layout and have a brief discussion about the kinds of things you have to do when you go to two sets of nozzles. The first thing to do is looking at the hat nozzle distribution. Okay. These start out 54s, 52s, 50s, 48s. This would be recommended if you have, especially if you have a large opening blower where the air fuel is dumped into the manifold over the entire length of the engine. Because of rotor twist, it tends to fling the fuel to the back of the manifold, and the band-aid for that is to put larger nozzles in the front, such as these, and go in 0.002 increments smaller as you go back through the engine. Now this would be a decision to do independent of whether you have port nozzles or not, because that's illustrated in this combination. The second part of this is the port nozzle layout, and making the move to port nozzles is a big jump compared to running hat-only nozzles. For what it's worth, we were able to run 6-second runs with hat-only nozzles and using a fuel distribution configuration such as that only. When we went to nitro, we had to go to port nozzles because we had to distribute the fuel to all of the cylinders. There was just simply a lot greater volume of fuel. Well, the problem with this engine is that it's in a funny car chassis and the engine tilts forward, so the front of the engine is lower. The problem with that is at idle, warm up and doing the burnout and doing the idle and backing up, the front of the engine got stone cold and we could not build heat in the engine. So what we did was we put smaller port nozzles in the front of the motor, and then we idled on the port nozzles as well as the hat nozzles. And then to balance out the heat of the motor would simply be an adjustment of small front and larger back port nozzles combined with large top and smaller rears underway to get a combination of good heat balance at low speed and idle, and then a good balance as you accelerate. Nozzle layout is an extremely extensive issue. It involves the acceleration of the vehicle or race boat. If it's a straight line vehicle, any excess fuel in the engine will run to the back of the manifold when the vehicle is accelerating. That may involve putting smaller nozzles in the back of the engine to handle the high end. and bigger ones in the front to handle the high end. And in the case of circle racing, where the vehicle is, or the race boat or car is underway for a long period of time, you may need to put your fuel bias in that direction to handle that, because you're not at idle, and the idle really doesn't care. The engine stabilizes. In the case of a circle vehicle or a circle boat, you may have all the fuel washing to one side if it's turning in the counterclockwise manner, or on this side if it's turning in the clockwise manner. So you may need to bias the fuel on short courses where maybe half of the time you're going around a turn. You may need to bias the fuel on one side or the other, and again, that can be done with port or hat nozzle fuel distributions. It is very lengthy. In our nitro book, we have an entire chapter on fuel distribution. When you go to add port nozzles, we have additional information about vehicle acceleration, deceleration, and turning in our other manuals as well. Thank you very much.